Here I'm going to go through a few of the important points regarding the coordinate geometry of a circle, specifically relating to some of the leave insert type questions that come up. So a bit similar to the line, we know that if the point exists on a line, then it satisfies the equation of a line. Likewise, if a point is on a circle, then it satisfies the equation of a circle. Now there's two common ways of looking at the equation of a circle, and luckily for us they're both in the log tables. I'm going to start with the most straightforward circle, which is the circle whose center is on the origin. So the equation of this circle is going to be x squared plus y squared is equal to r squared, where x and y are just coordinates on the circle and r is equal to the radius. So this distance here. So let's say, for example, x squared plus y squared is equal to 25 was the equation of a circle. Well, any point that satisfied that equation would be on the circle. For example, if x was 3 and y was 4, then 3 squared plus 4 squared is 9 plus 16 is equal to 25. The point 3, 4 is on that circle. The point 4, 3 is also on that circle, because 4 squared plus 3 squared is also equal to 25. So that's the circle starting at the origin whose radius is 5. So I've just moved that over to the side there. That's the most basic circle we'll come across. We can see what happens when we deviate the center from the origin then. Our equation becomes x minus h all to be squared plus y minus k all to be squared is equal to r squared, where r is the radius and the center of the circle is the point hk. For example, if I had a circle whose equation was x minus 2 squared plus y plus 4 squared is equal to 36, I can straight away pick apart some important information from that. I can say that the center is going to be hk, which is just 2 minus 4, and the radius of that circle will be square root of 36, which is 6. So the distance formula is equal to the difference between the x's squared plus the difference between the y's squared and the square root of that sum. So it's going to be 8 minus 2, which is 6 squared, plus minus 4 plus 4, which is 0 squared, and square root of that is 6. So it's equal to 6, so that's our radius. Hence, that point is on the circle. And the last way to look at an equation of the circle is actually just expanding out these brackets here, but it's written in a slightly different way. It's this one here. So it's the equation where x squared plus y squared plus 2gx, where g is just a number, and 2fy, where f is just a number, plus c, which is a constant, is equal to 0. So the center of this circle is minus g minus f, and the radius is equal to the square root of g squared plus f squared minus c there. So while that looks fairly complicated, we can gather some information from it. If the equation is written out in that way, then the center will be minus g minus f, so the center will be minus half of x coefficient and minus half y coefficient. So for example, if this was our circle, x squared plus y squared plus 26x minus 2y minus 15 equals to 0, any point, any x and y value, that is, that satisfied this equation would be on the circle. But to work out some other information, we could look at the center. Well, the center is going to be minus half the x coefficient, so the center here is going to be minus 3, minus half the y coefficient, which is 1, because minus half of 6 is minus 3, and minus half of 2 is just 1, and the radius is equal to root 3 squared plus 1 squared plus 15, which is root 25, which is just 5. So the leave insert style questions usually ask us to either find the equation of a circle given the center and given the radius, or else find the center and the radius given the equation of the circle, which we've just done, or you may be asked to find information about a tangent to a circle at a certain point. The key thing will be to use the formula that we have in the log tables accurately. For example, if you're told that two circles touch externally, then you're going to have to think about that and see, well, how does that situation arise? Well, if two circles touch externally like this, then if that's the radius of one and that's the radius of the other, then the distance between the centers is going to be equal to the sum of the radii. But if they touch internally, then the distance between the two centers is equal to the difference between the radii. So you could be asked about two circles which have a common chord, which is a line that cuts through the circle. Now to find, say this is circle 1 and that's circle 2, we're writing S because usually you write C for center. Then to find the chord, all we need to do is subtract S1 from S2. The reason we let it equal to 0 is because the equation of the first circle equals 0 and the equation of the second circle usually equals 0 as well, as per the standard way of writing it. So with the chord, you're going to get 2 points of intersection between the two, and with a tangent, you're going to get 1 point of intersection between the two. So, as I said before, we're usually asked to find the equation of a line which may touch the circle, or maybe a chord to the circle. If it's an equation of a tangent to a circle, which is just when it touches the circle, then we're going to use some coordinate geometry of the line. We need to find the slope of the tangent. So for any tangent, let's say this is our tangent, and it touches the circle at one point, B, and if this is our center, C, then we know that the slope of the tangent is going to be perpendicular to the slope of the radius. So if we know the center and we know the point at which it touches, then we can work out the slope of that line where the radius sits. Then we can work out the perpendicular slope, and we can use that slope and the point at B to find the equation of that tangent. So that's just a brief video introducing the circle, points on the circle, the center and the radius. We're going to be using the equation of the line and the equation of the circle to solve problems, usually involving the radius, a point on the circle, a tangent to the circle, or a chord within the circle.